Hi everyone, welcome back to Lessons in Chemistry. Today we are going to look at partial pressures under the topic of gas laws. Before we get into it, we first have to understand a few of the conversions that take place when you are using gas laws. The most common units that you will come across are kilopascals. 1 kilopascals is equal to 1,000 pascals. Keep in mind that a pascal has a unit of newtons per meter squared in SI units. You will also come across the atmosphere. 1 atmosphere is equal to 101.3 kilopascals, and this can also be equated to 760 millimeters of mercury. Finally, you will come across the bar. 1 bar is equal to 100 kilopascals. All of these conversions you are expected to know and be able to work with in different problems in VC chemistry. All right, now let's get into partial pressures. Let's understand the concept of partial pressures. Say, for example, you have a container containing the gas A, and it is at a pressure of 200 kilopascals. You also have 2 other gases, B and C, that are contained at the same volume container. Okay, as you can see, they are all of the same size. However, they have different amounts of pressure. So A is at a pressure of 200 kilopascals, B is at a pressure of 300 kilopascals, and C is at a pressure of 400 kilopascals. Now, what would happen if you empty all of A, B, and C into one container of the same volume? In that case, the resulting total pressure will be the sum of the individual pressures of each of the gases in the mixture. Okay, so as a result, your total pressure here was 200 plus 300 plus 400, which is 900 kilopascals. And that is the first law or first rule that you need to remember in terms of partial pressures as written here. The second rule that you are also expected to know is that the partial pressure ratio of the gases is going to be the same as the molar ratio of the gases in the mixture. Okay, so the only thing that differentiates them is essentially the number of moles of each gas that is present, okay? Because the volume and everything was the same across these containers. All right, now to understand the second rule a little bit better, let's look at an example. Say we have a mixture of 1 mole of hydrogen gas and 3 moles of chlorine gas in a container, and the container has a total pressure of 100 kilopascals. What is the partial pressure of chlorine gas going to be in the mixture? Well, let's first look at the molar ratio because we know what it is, right? We know that the molar ratio of your hydrogen gas to chlorine gas is going to be, hydrogen gas to chlorine gas is going to be 1 to 3, right? That's what we're given here. So from our second rule, we know that this is also going to be your partial pressure ratio. Now, how does this help us then to find our actual partial pressures? Well, if we have the total pressure, we can use the ratio of partial pressures to find the pressure of each individual gas, right? So we know that the partial pressure of hydrogen gas will be 1/4 of the total pressure, which is 100 kilopascals, which is going to be 25 kilopascals, and the partial pressure of chlorine gas is going to be 3/4 of your total pressure. should be kilopascals here, which is 75 kilopascals. All right, so that is how you use the second rule. Now, let's look at a more common problem that you will come across in VCE. So this problem here expects you to use your knowledge of various gas laws and partial pressures in order to solve it. Okay, this might be a 2 or 3 mark question. So let's have a go at answering this. Okay, so we have a mixture of 86.3 grams of CO2 gas and 50 grams of nitrogen gas. This occupies a container of total gas pressure 3.27 atm. If all of the nitrogen gas is extracted, what is the pressure of the remaining CO2 gas in kilopascals? So, before we do anything, let's convert the gas pressures into kilopascals, okay? Because that's the standard unit that you're expected to use. So we know from your conversions up the top over here, right? 1 atm is 101.3 kilopascals. So let's write that down. 1 atm is 101.3 kilopascals. Now, here we are given an amount of 3.27 atm. This is then going to be 101.3 times 3.27. All right? And this should give you 331 kilopascals. And this is the value that we're going to work with. Now, before we can find what we are looking for, which is the pressure of CO2 gas, we need to find the molar ratio. Okay, so that's going to be our steps. We're going to find the molar ratio, which is equal to the partial pressure ratio, and then we're going to use the total pressure in order to find what we need. So, for our molar ratio, we need to first find the moles of everything, right? So let's find the moles of our two substances. The moles of CO2 is going to be the mass divided by the molar mass, right? So this is going to be 86.3 grams divided by your molar mass of CO2, which is 44 grams per mole, right? So this gives us 1.96 moles. The second moles that we're finding is of nitrogen gas, so moles of N. Again, we're going to use mass over molar mass. This one is going to be 50 grams divided by 14 grams per mole. And this gives us 3.57 moles. All right, so then what is our molar ratio? Now, at this point, you may think to yourself, you can't really find a very nice, satisfying molar ratio because our values are in decimals. That is perfectly fine, okay? You can write your molar ratio in decimals for the sake of these types of questions, okay? So our molar ratio is just going to be for CO2, should not use the semicolon, the colon here. So CO2 to N is going to be 1.96 to 3.57. Okay, and we are saying that this is also our pressure ratio. Okay, now the next thing that you need to do is find what the actual partial pressure of CO2 is going to be. The partial pressure of CO2 gas is going to be the fractional amount of the moles of CO2 multiplied by the total pressure. So the fractional amount is going to be the number of moles of CO2, which was 1.96, divided by the total number of moles, which is 1.96 plus 3.57 multiplied by the total pressure, which was 331 kilopascals. Okay, so this gives you a partial pressure of 117 kilopascals, or if you would like to write it in scientific form, it is 1.17 times 10 to the 2 kilopascals. Note, I am writing my final answer to 3 sig figs because that is the least amount of sig figs in my question. All right, this is your final answer. Thank you for watching this video. If you enjoyed it, please leave a like, comment, and subscribe. And I look forward to seeing you in my next videos.